Um, I will present you today a tool I'm developing for 2 years now, which is called the Metabrik Platform. So first, who am I? I am an information security engineer since 15 years now, and in fact I started to develop in Perl at the same time I started my career. And I'm still learning Perl. That's an excellent language. I like it. And I am separator for a few modules. Maybe you have used them. My first try was Netpacket. It was a module to build easily network packets and send them to the network in a matter of a few lines. But it was quite complicated to understand how it was working under the hood, so I rewrote it to use NetFrame in more modular way, which is the preferred module today to craft network packets. I also write the NetWrite modules. You can send packets at layer 2, layer 3, or layer 4 directly on the network in the same way. And the last one of the series is NetSynFP. It's a complete operating system fingerprinting suite. Well, it's really oriented information gathering on the network. I have a question for you. Do you have already used Netpacket or NetFrame? Yes, at least a few people. Okay. So I'm a speaker at security conferences usually, so it's my first time speaker at a Perl conference, so first time at YAPC, or should I say the Perl conference now, and I just wanted to share my work with the Perl community. So what is Metabrik? In fact, it's the merge of 3 things I really love and enjoy playing with. The first one is a UNIX shell. We can do wonderful stuff from the command line. The second one, of course, is a Perl interpreter with a read, eval, and print loop. Python developers are really used to that. And many Briks. I will talk deeply about Briks in this talk. But basically, Metabrik is a development or a prototyping platform with the aim to build quickly the right tool when you need it. So why? I think everything should be possible from the command line. We can avoid to the maximum extent GUIs, maybe except for web browsing experience. And so we should be able to automate everything. And I also like the do it once principle. In 15 years of Perl, I ended up doing many times the same thing. I was sure I already did it in the past, but was not possible to find where is this script. So I was tired of repeated throwaway scripts, and I started this approach and oriented with code reusability. And UNIX shells were too simple. The pipe, to me, needed some tweaking. And to do my goal, I needed a powerful language, and as I mastered Perl, I use it, of course. And as I said, it's to quickly write the tool you need when you need it. Writing, you can do it from the command line or write a script like the standard way. And I normalized the syntax in a Newman readable form, because when you use one tool or another, they have a different syntax, and sometimes it's quite hard to remember. You have dash hell, what does that mean? We don't know, so using a human readable form is better. Another tool written in Python exists, which kind of achieves the same goal. It's to normalize. The goal is simply to normalize tool usage, and but the goal of Rebus is sort of replace the human. That is to automate interactions between tools, and that's not the goal of Metabrik. We just want to help the human, not to replace it. So Rebus is not a shell either, so I was interested in a shell. Usage is not so easy, and well, but basically both are using wrappers around existing tools. And Metabrik also has some specific bricks. And for each brick, I try to find and use the best CPAN modules. Sometimes it's not so easy because you have multiple modules achieving the same task, and you have to test them and see which one is better. So first demo, I will show the basic usage of the shell and what you can do with it. Well, it's a video because so I'm sure to not forget anything. So you launch it simply by typing Metabrik. As you can see here, I have a bunch of Briks which has been loaded when I started the shell. So it's a Perl REPL stuff, so you can just write whatever you want on the shell, and it will be interpreted by default as a Perl command. So for instance, you want to define an array, you just write it and it's saved as the name of the array, and there is an automatic dump if you just print something. So it's easy to look at basic structure. Here I just load a module, a standard module, and create. Sorry, there was a question? No. So here it is, and you see the object here is a blessed hash ref. So well, you can look inside the data easily. Here it's a shell, so we can cd to any directory. Here there is something happening under the hood. ls, in fact, is an alias to a Brik. The Brik is called shell command, and you can execute some commands on this Brik. And it basically captures the output of the ls command and pipe it through ls automatically, because that's really handy. And the result is automatically saved in a variable called $run for later use. It's an array, so you can just gather some element of the array. And the help is easy as help the name of the Brik, and you have all what is possible here. You have attributes. You set them using the set command. For instance, I want to execute the same command using sudo, so I enable the use sudo flag, and the result of the set command is automatically saved in the set variable. Same for the get command. And so now I execute the same command, and it automatically adds the sudo, and I have the content of the ls command. Well, same for find. Well, it's an alias also, so anyway. Features. I will speak about the most notable ones. As this is a shell, you have the built-ins, cd, alias. You can customize the shell using the .metabrik rc file. You execute whatever program you want, or you load Briks, you set attributes, all of that. For those familiar with penetration testing and meta-exploit, I try to have a similar syntax. You have completion for commands, for files, for variables, which is quite handy. And also it's GNU readline for the command line. So you have the GNU readline keystroke like Ctrl R, which basically grep in your history of commands. So what is a Brik? The goal behind the Brik is that you want to do something, but you don't want to deep into the detail on how to do it. So it's wrappers around external programs, but not only. And a Brik, you guess it, is object-oriented, and thus can inherit attributes or commands from other Briks. For instance, if I take the file PSV Brik, which basically reads a file as the PSV format, the pipe separated values, it just inherits from the file CSV Brik, and you just replace the separator attribute by the pipe or whatever, and you have a new Brik in a matter of seconds. Thanks to Briks, you can also add features to already existing tools. I find very often using a tool and wishing there is that features. Sometimes it's quite simple to add it, and sometimes it's not so simple. And thanks to this, we can just add features easily, and it's totally transparent for the user. In the end, a Brik is simply a reusable Perl module, which has a command line interface, if you have seen it, and a classic interface. You can program your Perl script or Perl program, whatever you want, easily. So, within Briks, we have two kinds of dependencies. Sometimes you have to install some system packages, and sometimes you have to install Perl modules. And I made this process as easy as calling the Brik tool install command, and it will, depending on your system, install the correct package, the correct system package, and install the correct Perl dependence. So if you want to use nmap to scan your network, you just run Brik tool install network nmap, and then you can start using it with use command. And you just type help on it, and you see what you can do with the Brik. Metabrik is an evolving platform, and so we have to be able to update it easily. And the Brik tool, again, comes to the rescue. You can simply run Brik tool update, or if you want just to update the core, you can update core directly, or the repository. Repository is where every Briks are stored. There are some special variables. You have seen some of them during the first demo. So you can play with the $run variable every time you have run command. So this is really where I tried to create a new kind of pipe, because basically it's like a breakpoint in a pipe command. You play with the variable, you modify it, you increase it if you want. And you can just sculpt it to your needs and give it as food for the next Brik. You have other special variables. We have seen set and get. The four next one, con, log, glow, and shell, means shell, the last one, are basically pointers to the four primary Briks which compose Metabrik. In fact, Metabrik is also written using Briks. And if you want to go within the Metabrik, in the internals, you can call these objects. This is really objects behind these variables. And you have use, R, MSG, ref. So this demo is how to quickly solve a problem, how to solve a foresting challenge. On the rootme.org, you have some small exercises where you have a question and you try to solve the question. Here, one of the challenge is your cat has been kidnapped by some miscreants, and you found on the crime scene some device with some data within it, and you have to dig within this data to find some proof or evidence to who did that and maybe where is the cat. So demo. So you are in the shell, you have an archive, you have two files. So I save the files for later use. First thing is which kind of file is it, so you want to get the MIME type of the files. So here the command takes an ref as an attribute, so it does that for every file you have saved in the variable. I also like to get the magic type. Sometimes there are some differences. Here there is no real differences, so we really have a JZip file. So it's a JZip file, so we can use the Brik to uncompress it. As you can see, the syntax is normalized. You just call uncompress. It's not gunzip or whatever. You just uncompress. It takes care of the rest, being zip or whatever. So we have a first result. This time we will run again get mime type and get magic type. I should write another command to do both directly. That would be easier. And here we have a sort of DOS partition. So we have to dig within the DOS partition and see what we have inside. This is where we will use a forensic tool called Scalpel. Well, it's already used, so there is a warning displayed. The first thing to do is to configure the tool. It can be quite complicated, but thanks to the generate conf command, you just specify which kind of data files you want to extract. In fact, Scalpel will search some files to extract. Here, I know the result of the challenge, so I go directly with what I'm interested in. I want to extract some OpenOffice document because I know that that's what is inside. So I generated a configuration file. Now I can scan the file. Here you can see there is two keys in the resulting href. One is called unverified and the other one is called verified. In fact, Scalpel does not verify the mime tip or the magic tip of a file. That was something limiting. So in the scan command, I added the automatic checking of mime tip and magic tip. And if the file here is ODT and it's really an OpenOffice document, it ends up in the verified href. So it's make your life easier as a forensics engineer, for instance. So I know where is the result. So again, I will just keep the file where is the result to be more efficient here during the demo. So I will again check the mime tip and the magic tip, but it's really not necessary here because, as I said, the Brik already checked this file. So as we can see, it's really an open document text. So what you may be aware of is that open document text is also a compressed format. So you just call again the Brik file compress and the uncompress command, and it will just unpack the archive. I know where is the result again, so I go directly to the good file. There is a picture. It's a JPEG, so I want to look at the metadata. Oh yes, again, I check the mime type and the magic type. That's sort of habit. So it's really a JPEG image data. So I will extract metadata from it. So here it is. You have all the information you want. There is it's an iPhone, and more importantly, you have some GPS coordinate. So that would be really awesome if there could be the position of the cat you're trying to find. Yes, that was the position of the cat. So voilà. It's just a forensic challenge. You have some stuff to do, and as you can see, this is really a normalized syntax to do whatever you want. You use always the same syntax. It's as easy. You don't have to learn a new tool again and again. So 2 Briks are really important because today there is more than 200 Briks. That may be quite a mess to find them. So I developed the Brik search, where you can just search Briks by tag, by command, by category or string. Category is the first part of the name. What would I say? Search by tag. Yes, because each Briks has some tags associated to it. It's like a tag cloud. Brik tool for management. I spoke about Brik tool for dating the system or stuff like that. But you can also create some Brik directly from Brik tool. It creates a skeleton of a Brik. That's really handy. You just have to fill the missing commands and you have a new Brik. You can also create a skeleton of a new program because you have to write some some prologue to start a script in Metabrik. I call that a meta tool, but it's really a Perl script. You have here you have 2 commands on line 2 and 3. This is directly from the command line interface. But if you want to do the same thing on a Perl program, it's starting from line 6. You load the main Brik of Metabrik, and then you load the Brik you want to use. Here we want to perform a lookup IP to geo, so geo IP. And you call it nearly exactly in the same way you call it from the command line. So you can prototype in the shell and write finally a script for it to use. So the demo 3 will not do it here because it is quite complicated to explain in a few minutes left. How to contribute? I don't like GitHub. That's my personal view. So I prefer to host my code, and so you have a Mercurial repository available, and you also have a track if you want to report some bugs on the track interface, which is a ticketing system. So if you want to write Briks, don't hesitate. It's not too complicated. I have to blog a little bit more about that. It's really production ready. I use it daily. I use it every time. There is more than 200 Briks, so starting to do some cool stuff with that. So there is a blog. I should blog more often, as I said, some tutorial on how to create Brik, for instance. The code is available. There is a Twitter account, Metabrik. So, in fact, I have a few minutes left, so I will try the last demo. So, what was the last demo? Yeah, say you have malware you want to analyze, so it's more for reverse engineer here, and but well, you don't have really the necessary skills to reverse engineer like I am. I'm not a good reverse engineer. So you just want to launch a malware in a virtual machine which will be sacrificed. You just snapshot it before and restore after the launch of the malware. And the idea is to take a fingerprint of the memory, process, registry of the VM before running the malware. And you do that after running the malware, and the diff will give you what we call indicators of compromise, like specific registry keys, specific processes, all that stuff. And to do that, you want to, from the command line, of course, you want to do it with some Briks. So for the demo. Okay. So the virtual machine is already, you can list here with this Brik which kind of virtual machine, which virtual machine are available. You have FreeBSD, you have a Windows machine. So you want to start a virtual machine. There is an error here because the virtual machine is already started. You will not see the virtual machine because it's started in headless mode. So you will not see the Windows machine here. So because I really prefer command line interface than Windows interface. So I don't want to see that. So you will execute a command remotely using WinExe. Here, just a test, you execute cmd.exe on the remote machine here, so it's okay. You have a remote shell, but there is no magic here. You can execute a program remotely on the Windows using WMI. You can also execute, well, some WMI stuff. For the purpose of this exercise, I will not execute a malware, but I will execute calc.exe, which is a classic example we use. So the idea will be to verify before and after if the process is here, just for demonstration purposes. So if you call a get process list, you have as a result an array ref, and you can play with it from the command line. So now I will execute calc.exe. In the video it was quite quick, but I verified beforehand that calc.exe was not running. So now I execute it remotely. I search in the process list again, so this one calc.exe successfully run. And this one is interesting. This command will just dump the complete memory of the virtual machine, and we will do the same exercise, but using another tool which is called volatility. For people doing forensic analysis, volatility is a wonderful tool. In volatility, you can load ELF program, but when you call the dump guest core feature of a virtual machine, it does not. The dump guest core feature of VirtualBox dumps an ELF file, but volatility don't want an ELF file. It does want just the portion of memory which is useful for its analysis. So we have to extract from this ELF file just the memory dump of the guest core. So I wrote the command because there was no tool readily available on the internet to do it. So now it's done. You don't have to remember how to do it manually with xdump and all that stuff. So we are just dumping the content of the memory. So now you have a valid file to be used by forensic volatility tool. One of the commands is pslist. If you just do that, it prints usage, so it's easy to use it without really knowing by heart how does that work. So you do a pslist and you have again the calc.exe. So this is really how you can automate the process of making a diff. This is just a proof of concept here. This is not the full stuff, but you can automate the process of making a diff on the state of a machine, for instance. So conclusion, and this is done for me. It's quite easy to install too. There is a how-to on the website. There is a Metabrik Twitter account and my personal Twitter account too. Any question?
Yes. Just a question about logging. I don't know much about forensics myself, but I would think that logging what you're doing and logging what you've done for evidence purposes would be important. Do you have any special interfaces or special methods that you use?
I'm sorry, could you repeat the question?
Okay. This is more about tracing your steps in forensic analysis. Do you have anything special in the Metabrik architecture to log?
Yeah, there is a complete logging available here. Because in fact, one of the 4 Briks used to write Metabrik is the logging Brik, in fact. So there is a global one which stores some specific information related to Metabrik itself. There is a log one, which is a Brik, and you can plug your own logging Brik if you want. So I have a Brik to log directly to files, for instance, so you have no output and everything is logged to files. You can even dual log if you want, so you have the output and you also have the output on the file. There is a core context Brik, which really stores all the context and available variables and that stuff. And the 4th one, I don't remember, but that's not very important. So I hope it answers the question. Yeah. Any other question? No? Okay, so thank you.